we have discussed arithmetic sequences. What is an arithmetic sequence? It's a sequence in which each term is obtained by adding a particular number to the previous term. And we have discussed common difference. It is the number which is added to each term to get the next term. And we have also seen that the common difference can be positive, negative or zero. When the common difference is positive, the terms goes on increasing, and when it is negative, it goes on decreasing, and when the common difference is zero, it remains unchanged. I have given you some assignments also. I have asked you to write down all the sequences which we have discussed so far and find out the arithmetic sequences among them. I think we have all done that. Now, we can easily make an arithmetic sequence when the first two terms are given. For example, 5 is the first term, 10 is the second term. Then the sequence is 5, 10, 15, etc. Again, we can make an arithmetic sequence when any two consecutive terms are given. For example, suppose the third term is 3 and fourth term is 4. So we know the common difference is 1, then the second term is 2 and the first term is 1, and the sequence is 1, 2, 3, 4, etc. Can you make an arithmetic sequence when the first term and third terms are given? Can you make an arithmetic sequence when the first term and the fifth terms are given? Can you make an arithmetic sequence when any two terms of an arithmetic sequence is given? Today, we are going to learn the relation between position and term to find out the answer to all these questions. Consider the sequence 5, 10, 15, etc. Let me tabulate it. First term is 5, second term is 10, third term is 15, fourth term is 20, fifth term is 25, sixth term 30, seventh term 35, eighth term 40, ninth term 45, 10th term 50. Now, what is the common difference of this sequence 5, right? Now let me find the difference between second term and first term. x2 minus x1 equal to 5, right? Now what is the difference between third term and second term? That is 15 minus 10, again 5. What is the difference between fourth term and third term? 20 minus 15, again 5. What is the difference between fifth term and fourth term? Again 5. It continues like this. We know that the difference between any two consecutive terms is the common difference. Now let me find the difference between third term and first term. The third term is 15 and first term is 5, so the difference is 10. Now take fourth term and second term. The difference is 20 minus 10, again 10. Now take fifth term and third term. The difference is again 10. What is the difference between sixth term and fourth term? Again 30 minus 20 is 10. So in all these cases, the difference between the terms is 10. Is it related to the common difference? Of course, it is 2 times 5 or 2 times common difference. So we can see that the difference between alternate terms of an arithmetic sequence is 2 times common difference. Now let us observe the positions. Here the position is 3 and this is 1. What is the difference between 3 minus 1? 2. Now find the position difference in the second example, 4 minus 2, again 2. In the third example, 5 minus 3, again 2. And in the fourth line, 6 minus 4, again 2. So in all these examples, the position difference is always 2. And we have seen that this term difference 10 is 2 times 5 or 2 times common difference. So what did we see? The term difference is 2 times the common difference, or term difference is position difference into common difference. Is it true in all the cases? Let us check. Now let me find the difference between fourth term and first term. Fourth term is 20 and first term is 5 and the difference is 15. Now fifth term minus second term, again 15. Sixth term minus third term, 30 minus 15, again 15. Seventh term minus fourth term, 35 minus 20, again 15. So here also all the term differences are same. Is it related to the common difference? Of course, it is 3 times common difference. Now look at the position difference. 4 minus 1 is 3, 5 minus 2 is 3, 6 minus 3 is 3, 7 minus 4 is again 3. So here also we can see that the term difference is position difference into common difference. Let us take another example. Fifth term minus first term, that is 25 minus 5 or 20. Sixth term minus second term, that is 30 minus 10, again 20. Seventh term minus third term, again 20. Eighth term minus fourth term, again 20. Here I have taken all the examples where the position difference is 4. Now look at the term difference. It is 4 into 5 or position difference into common difference. Now let me take the cases where the position difference is 5. That is sixth term minus first term, that is 30 minus 5 or 25. Seventh term minus second term, again 25. Eighth term minus third term, that is 40 minus 15, again 25. Ninth term minus fourth term, that is again 25. It continues like this. So here also we can see that the term difference 25 is 5 times common difference and position difference is 5. So from this also we have seen that the term difference is position difference into common difference. So we can say the difference between any two terms of an arithmetic sequence is the product of the difference of positions and the common difference, or we can say term difference equal to position difference into common difference. From that we can find common difference. Term difference equal to position difference into common difference. Therefore common difference equal to term difference by position difference. Term difference equal to position difference into common difference. So we can say in an arithmetic sequence, term difference is proportional to position difference, and the constant of proportionality is the common difference. Always term difference equal to a constant, that is common difference, into the position difference. In this we saw one more thing, that the difference between any two terms in an arithmetic sequence is always a multiple of the common difference. We have seen that term difference equal to position difference into common difference. So the difference between any two terms is always a multiple of common difference. We can use this idea to check whether a particular number is a term of an arithmetic sequence or not. Now let me take an example. Make an arithmetic sequence with 1 and 11 as the first and second terms. Then make an arithmetic sequence with 1 and 11 as the first and third terms. In the first case it is very easy. 1 is the first term, 11 is the second term, and therefore the common difference is 10. So the sequence is 1, 11, 21, etc. And in the second case, 1 is the first term, 11 is the third term. What is the difference between third term and first term? It is 2 times common difference. Therefore common difference equal to term difference by position difference. Third term minus first term by 3 minus 1. The positions are 3 and 1. Third term is 11, first term is 1, and 3 minus 1 is 2. So we will get 10 by 2 or 5. That is, the common difference is 5. And given that the first term is 1, so the sequence is 1, 6, 11, etc. Now let us take another example. Make an arithmetic sequence with third term 37 and seventh term 73. Find the 25th term. Given that seventh term is 73 and third term is 37. We know common difference is term difference by position difference. That is seventh term minus third term by 7 minus 3. That is equal to 73 minus 37 by 4. And what is 73 minus 37? That is 36. So it can be written as 36 by 4 or 9. So in this case, the common difference is 9. Now we have to find the sequence. It's given that third term is 37. If you subtract common difference from the third term, you will get the second term. So 28 is the second term. Again, if you subtract the common difference 9, we will get the first term. 28 minus 9 is 19. So 19 is the first term, 28 is the second term, and it is already given that 37 is the third term. So the sequence is 19, 28, 37, etc. Now we need to find the 25th term. We can find it in two different ways. Given that third term is 37, when you add 22 times common difference to the third term, you will get the 25th term. 3 plus 22 equal to 25. If you add common difference to the third term, you will get fourth term. If you add 2 times common difference to the third term, you will get fifth term. If you add 22 times common difference to the third term, you will get 25th term. So we can say 25th term equal to third term plus 22 times common difference. Here third term is 37 and common difference is 9. Let us multiply at first. What is 22 into 9? It is 198. So we can write 37 plus 198 and that is equal to 235. So 25th term equal to 235. We can find 25th term from 7th term also. 7 plus 18 equal to 25. That means if you add 18 times common difference to the 7th term, you will get the 25th term. So we can write 25th term equal to 7th term plus 18 times common difference. That is 73 plus 18 times 9. Let us multiply 18 and 9 first. So we'll get 73 plus 162 and that is equal to 235. So we can find 25th term using third term. Again we can find 25th term using 7th term. Now let us do some more problems. In each of the arithmetic sequences below, some terms are missing and the positions are marked with a round. Find them. Let me take the first problem. 24, 42, then around, again around. We have to find the two terms. Given that these are arithmetic sequences, then what is the common difference? 42 minus 24, that is 18. So if you add the common difference 18 to the second term, you will get the third term. So the third term is 42 plus 18, that is 60. Again add the common difference, you will get the fourth term, that is 78. Now the second question, the first two terms are missing, 42 and 60. Again the difference between 42 and 60 is 18. So the common difference of this sequence is 18. 42 is the third term. Subtract 18 from that, you will get the second term. So 24 is the second term. Again subtract 18, you will get the first term, that is 6. 6 is the first term. The third problem, first term is missing, second term is 6, third term is missing, fourth term is 42. What is the difference between fourth term and second term? We know that is 2 times common difference. What is the difference between 42 and 6? That is 36. So 36 is 2 times common difference. So common difference equal to 36 by 2 or 18. So when you add 18 or the common difference to the second term, you will get the third term. So 6 plus 18, that is 24, is the third term. Now, to get the first term, subtract 18 from the second term. So, negative 12 is the first term. The fourth problem, first term is missing, second term is 33, third term is 42, and last term is missing. Here the common difference is 42 minus 33, that is 9. If you add 9 to 42, we'll get the fourth term, that is 51. And if you subtract 9 from 33, you'll get the first term, that is 24. The next one, second term is missing and fourth term is missing. We know the difference between third term and first term is 2 times common difference. So what is the difference between 33 and 15? That is 18. That is 2 times common difference means common difference is 9. So adding 9 to the first term, we'll get 24 as the second term, and adding 9 to the third term, we will get 42 as the fourth term. The next one, 24, second term is missing, third term is missing, and last term is 42. What is the difference between fourth term and first term? That is 3 times common difference. And now what is the difference between 42 and 24? That is 18. So 18 is 3 times common difference. So common difference equal to 18 by 3 or 6. So adding 6 to the first term, we will get second term as 30. Again adding 6 to it, we will get the third term as 36. Now the next problem, the terms in 2 positions of some arithmetic sequences are given below. Write the first 5 terms of each. The first problem, third term is 34 and sixth term is 67. We need to find the first 5 terms. Let us find the common difference at first. We know common difference is term difference by position difference. That is 6th term minus 3rd term by 6 minus 3. Here 6th term is 67 and 3rd term is 34. So 67 minus 34 by 3. That is 33 by 3 or 11. So 11 is the common difference. Subtracting 11 from 34, we will get 23. That is the second term. Again subtract 11 from 23, we will get 12. That is the first term. So the terms are 12, 23, 34, 45, 56. These are the first 5 terms. The second problem is third term is 43 and sixth term is 76. Again we have to find the first 5 terms. The common difference is 6th term minus 3rd term divided by 6 minus 3. That is 76 minus 43 by 3 or 33 by 3. Again the common difference is 11. Subtracting 11 from 43, we will get the second term, that is 32. Again subtracting 11 from 32, we will get the first term, that is 21. So the terms are 21, 32, 43, 54, 65. Third question, third term is 2, fifth term is 3. We have to find the first 5 terms. Common difference is fifth term minus third term by 5 minus 3. That is 3 minus 2 by 2. That is 1 by 2. That is the common difference is 1 by 2. Subtracting the common difference from third term, we will get second term as 1.5. And again subtracting, we will get the first term as 1. So the terms are 1, 1.5, 2, 2.5, 3. Next problem. Fourth term is 2, seventh term is 3. The common difference is 7th term minus 4th term by 7 minus 4. That is 3 minus 2 by 3, or that is equal to 1 by 3. Here the common difference is 1 by 3. How will you get first term from fourth term? Subtract 3 times common difference from the fourth term. What is 3 times common difference? 3 into 1 by 3. 3 into 1 by 3 is 1. So subtract 1 from the fourth term 2. We will get the first term. So the first term is 1. Now add the common difference. Second term is 1, 1 by 3. Again add the common difference. Third term is 1 2 by 3. Again add 1 by 3. Fourth term is 2. Again add 1 by 3. Fifth term is 2 1 by 3. Next question. Second term is 5. Fifth term is 2. Let us find the common difference. That is fifth term minus second term divided by 5 minus 2, or 2 minus 5 divided by 3, or minus 3 by 3. That is minus 1. Here the common difference is minus 1. So subtract minus 1 from 5 to get the first term. That is 5 minus minus 1. That is the first term. 5 minus minus 1 means 5 plus 1. So 6. Next problem. Second term is 5. Fifth term is 2. The common difference is fifth term minus second term divided by 5 minus 2. That is 2 minus 5 divided by 3. That is minus 3 by 3. That is minus 1. So the common difference is minus 1. Subtract minus 1 from the second term to get the first term. That is first term is 5 minus minus 1. 5 minus minus 1 means 5 plus 1. So 6 is the first term and common difference is minus 1. So 5 is the second term. Again subtract 1. 4 is the third term. Again add minus 1 or subtract 1. 3 is the fourth term and 2 is the fifth term. Next problem. The fifth term of an arithmetic sequence is 38 and ninth term is 66. What is its 25th term? Given that fifth term is 38, ninth term is 66. Common difference is ninth term minus fifth term by 9 minus 5. That is 66 minus 38 by 4. That is 28 by 4 or 7. So the common difference is 7. Now we have to find the 25th term. 25th term equal to fifth term plus 20 times common difference. You can find the 25th term using ninth term also. 25th term equal to ninth term plus 16 times common difference. So here I have used fifth term and fifth term is 38. Common difference is 7. So 38 plus 20 into 7. Now 20 into 7 is 140. So that is 38 plus 140, or that is equal to 178. That is the 25th term is 178. Now the next problem. Is 101 a term of the arithmetic sequence 13, 24, 35? What about 1001? We know the difference between any two terms of an arithmetic sequence is a multiple of the common difference. So let us first find the common difference. What is the common difference of the sequence 13, 24, 35, etc.? It is 24 minus 13 or 11. So the common difference is 11. Now let us check whether 101 is a term of this sequence or not. Let us subtract the first term 13 from 101. What is 101 minus 13? It is 88, which is a multiple of the common difference 11. Therefore 101 is a term of this sequence. Now let us check whether 1001 is a term of this sequence or not. Again let us subtract the first term 13 from 1001. What is 1001 minus 13? It is 988, which is not a multiple of 11. Therefore 1001 is not a term of this sequence. Next problem. How many 3-digit numbers are there which leave a remainder 3 on division by 7? Here we have to look only on 3-digit numbers, that is starting from 100 and ending at 999. And we have to select only those numbers which leave a remainder 3 on division by 7. And we have already seen that this will be an arithmetic sequence with a common difference 7. So let us find the first term at first. 100 is the first 3-digit number. Let us check whether this is the first term or not. If it is the first term, it should leave a remainder 3 on division by 7. So let me divide 100 by 7. 1, 7 is 7 and 3 remainder. Now put the 0, it is 30. How many 7s are there in 30? 4 7s, right? That is 28. What is the remainder now? 2. So when you divide 100 by 7, the remainder is 2. We have to get the numbers which leave a remainder 3 on division by 7. Here the remainder is only 2. How can we make it 3? Just add 1. When you add 1, the number changes from 100 to 101. That means when you take 101, it will leave a remainder 3 on division by 7. So the first term of the sequence is 101. Now what is the last term? The last 3-digit number is 999. Again, let us check whether this is the last term of the sequence. If it is the last term, it should leave a remainder 3 on division by 7. So let me divide it by 7. 1 7 is 7, 2 remainder, and make it 29. And 4 7s are 28, 1 remainder, and write down the 9. Now it is 19. How many 7s are there? 2 7s are 14. And what is the remainder? 5. Here the remainder is 5. And we need to get the numbers which leave a remainder 3 on division by 7. How can we make this 3? Just subtract 2. When we subtract 2, this becomes 3. And when we subtract 2, the number becomes 997. So 997 is the last term. I don't know the position of the last term. So let me write it as nth term or xn. So the last term is 997. Now we know it is an arithmetic sequence with common difference 7. We have already seen that when we divide numbers by 7, we can make sequences. The multiples of 7, the numbers which leave a remainder 1 on division by 7, those numbers which leave a remainder 2 on division by 7, like that. And all these sequences are arithmetic sequence with common difference 7. So here also the common difference is 7. And again we have learned that the difference between any two terms of an arithmetic sequence is always a multiple of 7, the common difference. So let us find the difference between the last term and first term. That is 997 minus 101. That is 896. So this difference between the first term and last term, it must be a multiple of 7, the common difference 7. So let us divide this by 7 and find out the quotient. So we can see this 896 equal to 128 into 7. Here 7 is the common difference. And since we have found the difference between the first and last terms, surely it must be a multiple of 7 or a multiple of the common difference. Now what does it mean? The difference between last term and first term is 128 times common difference. That means when you add 128 times common difference to the first term, you will get the last term. We have seen that if you add common difference to the first term, you will get second term. If you add 2 times common difference to the first term, you will get third term. If you add 3 times common difference to the first term, you will get fourth term. So if you add 128 times common difference to the first term, we will get the last term. So what will be the last term? When we add 128 times common difference to the first term, we will get 129th term. So the last term of this sequence is 129th term. Means there are only 129 terms. Now the sixth problem. Fill up the empty cells of the given square such that the numbers in each row and column form arithmetic sequences. What if we use some other numbers instead of 1, 4, 28 and 7? So let me take the table. Given that in the first cell it is 1 and here it is 4, 7 and 28. We have to find the numbers in such a way that each row is an arithmetic sequence and each column is an arithmetic sequence. So let me take this row. 1 is the first term, 4 is the fourth term. It is very easy. The terms are 2 and 3. 1, 2, 3, 4. These are the terms. Now let us take the last row. 7 is the first term, 28 is the fourth term. And we know fourth term minus first term is 3 times common difference. So 21 is 3 times common difference. So common difference is 21 by 3 or 7. So the second term is 7 plus 7, 14. Third term is 14 plus 7, 21. And you can check again, if you add 7 you will get 28. Now let me take the first column. The term difference is 6 and position difference is 3. So the common difference is 2. Therefore the second term is 3 and third term is 5. Now let me take the last column. Term difference is 24. Position difference is 3. So common difference is 8. 4 plus 8 is 12. 12 plus 8 is 20. Now let me take the second row. The term difference is 9. Position difference is 3. So the common difference is 3. Second term is 6. Third term is 9. Now the third row. Term difference is 15. Position difference is 3. So common difference is 5. So second term is 10 and third term is 15. Now the second part of the problem, you can do it by taking some other numbers. Today we have discussed the relation between position and term, and we have seen that the difference between any two terms of an arithmetic sequence is the product of the difference of positions and the common difference. Or we have seen that common difference equal to term difference by position difference. And we have also discussed that in an arithmetic sequence, term difference is proportional to position difference, and the constant of proportionality is the common difference. We have also seen that the difference between any two terms is a multiple of common difference. Now there are two assignments. First one is every power of 10 from 100 onwards a term of the arithmetic sequence 19, 28, 37, etc. Second assignment, in the table below some arithmetic sequences are given with two numbers against each. Check whether each belongs to the sequence or not. We have to check whether 123 is a term of the given sequence 11, 22, 33, etc. So that also can be done as a home assignment. Hope you have understood. Study well. I'll be back with another video. Till then, bye.